Example 4.5. A site is currently under consideration for a bridge over a small river. The suspension bridge will cost $500 million with annual inspection and maintenance costs of $350,000. In addition, the concrete deck would have to be resurfaced every 10 years at a cost of $1 million. The cost of purchasing right-of-way is expected to be $20 million. Determine the capitalized cost if the interest rate is 6% per year. What this problem is asking us is to determine the capitalized cost. So this new word that we have here, let's go to the notes, it's basically the present worth. So we're still calculating the present worth, but it's going to be for an alternative with an infinite life, and quote-unquote infinite, because it will not literally last forever, but it just means that the end will be a very big number. For example, the Golden Gate Bridge. This bridge was built in the 1930s and it's still standing. Okay, so it's a very long period of time. So the end here tends to approach infinity. Okay, that means that you're going to be using a very large number for n. If we look at, well, we're going to be converting to p because it's the present worth. Okay, so, but if we look at this formula right here, we're going to be plugging in a very large number for n. If we raise 1 point something to the nth power, or to a very large number, then the denominator is going to result in a very large number. If this happens, and if we try to divide 1 by a large number, the larger the number, the more this division right here is going to approach to 0. Therefore, we are only left with this part of the equation or the formula, meaning that it's going to be a divided by I, or the way they put it here, a times 1 divided by I. So this will be our formula to calculate the present worth or the capitalized cost. Okay, so then again, this is a formula, a divided by I. There may be some cash flows that we first need to convert to the equivalent A, that's why they call it the annual worth, and then we must divide that by I. In order to do this, we need to identify 2 types of cash flows in our problems. The first one would be recurring. Recurring means that the cash flows are going to repeat. An example would be your A. So it's the same cash flow and it occurs annually. But we can also have cash flows that repeat every 5 years, every 10 years, etc. All of those would be recurring. Non-recurring cash flows are one-time payments. Your investment would be a non-recurring. Maybe we have some kind of expense in year 5, but you don't have that expense repeated anywhere else, so it just happens once in the lifetime. So that would also be considered non-recurring. Okay, so you identify both of them. Then we need to follow this set of steps in order to find the total capitalized cost. First of all, we're going to be drawing a diagram for 2 cycles of all of the recurring and non-recurring amounts. So we're going to make sure that all of the recurring cash flows are there and any non-recurring are repeated at least twice in the diagram. Then, step number 2. We're going to calculate the present worth for non-recurring first. And we're going to call that capitalized cost 1. Step number 3, we're going to find the annual worth for 1 cycle only of the recurring. Okay, then again, you may have more than 1 recurring, so you may need to have A1, A2, A3, and so forth. It's easier if you organize it that way. So if you split it into an A for each and one of the cash flows. Then after you have found all of your annual worths, we're going to transform that into capitalized cost, meaning that we're going to be recurring to the formula that we mentioned in the previous slide. So it's going to be the annual worth, which is the sum of all of these, and you divide it by the interest. We're going to call that the second capitalized cost. And then the last step, we need to find the total, so therefore we're just going to add what you got in step number 2 and what you got in step number 4. So it's the addition of CC1 plus CC2. Okay, so now let's go back to the example and let's follow all of those steps. Okay, so we mentioned that step number 1, it's draw a diagram for 2 cycles. Okay, so if we look at everything we have here, we have the initial cost, then annual inspection and maintenance that is repeated every year. Then it says that the concrete deck would need resurfacing every 10 years. Okay, so this one gets repeated every 10 years. That means that if you want it to appear at least twice in your diagram, it has to go up to year 20. Then the cost of purchasing right away, that's a cost that occurs in year 0 because you need to purchase a right away before you start building your bridge. And that's all we have. So our diagram has to be 20 years long. Okay, so we're going to have year 0, 10, and 20. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, we know that the interest rate is equal to 6% per year. Okay, so we start drawing the cash flow, so we know that the initial cost, it's 500 million. Then the resurfacing occurs, oh no, I'm sorry, the inspection and maintenance, it's annual, so we're going to have an arrow going down every year. Almost there. Okay, so here we have the 350,000. Then the resurfacing occurs every 10 years, so that means in year 10 and year 20. So you're going to add 1 million. And the right of way, which occurs in year 0, of 20. Okay, so we have everything we need. Then, step number 2 says that we must calculate CC1, which is basically the present worth of non-recurring. Okay, so we said that these are the costs or the cash flows that occur only once in the diagram. And in this case, we only have 2. We have the 500 million and the 20 million. So I'm going to list them here. We have the initial cost, which is 500. And we have the right of way, which is 20 million. Okay, so how do we find the present worth of these two? Well, the good thing is that they are already in year 0, so they are already in the present. And they're going down because these are costs, so we're going to put them as minus 500 million, and this one is also an expense, so minus 20 million. We're going to have a total of minus $520 million. Okay, then again, they will not necessarily always be in year zero. You may have a random expense over here that you need to move to P. But in this case, they were already in P, so we're all set. Step number 3. Well, let me just, for your reference, let's just say that this is P and this is also P. Okay, so then our next step, number 3, is to find the annual worth of one cycle of the recurring costs. Okay, only one cycle. Okay, so if we only need to find the annual worth of one cycle, then why did we draw the diagram for 2 cycles? Okay, so the only reason why we draw the diagram for 2 of the cycles, if we're only going to be using one, is for you to be able to identify the recurring costs. Because let's say that we were only drawing a diagram for 1 cycle. Okay, so just focus on the selected area. Then you would probably think, if you only look at this part, you would probably think that the 1 million, it's a non-recurring cost because you will only see it once. Okay, so you may say, okay, that only happens once, and you may accidentally put it under the CC1. So that's why you should draw it for 2 of the cycles, because that way you'll know, oh, the 1 million repeats here, and then it gets repeated over there. So that's the only purpose of drawing the 2 cycles in your diagram. But we're only going to be using one for in order to solve the problem. So let's list our recurring amounts here. We have the annual inspection. This is the 350,000. And then we have the resurfacing. Hold on. Can't tell what it says. Resurfacing. Okay, so this one happens every 10 years. And this is for 1 million. So this is where you have to split it into the 2 A's. Let's look at the first one, the annual inspection. We're gonna call this A1. That one, it's super easy because it's already in A. So remember, we're trying to find the annual worth. Oops, let me change it to black. Okay, so A1 will be the minus, and it's going down, so make sure that you put the right sign, minus $350,000 per year. It has to be annual worth. So A1, it's already occurring every year, so that's perfect. We leave it as is. But then we have to find A2. In this case, even though the 1 million gets repeated, it's not an A because it doesn't happen every year. Then again, go back to where it says 1 cycle of recurring. So now it's time for us to just focus on this part. And we need to find the annual worth of the 1 million. What do we do in this case? If we want to divide this into equal cash flows among the 10 years, because that's 1 cycle, then your 1 million is actually going to be an F. And we need to convert that F into A. So this is how you're going to do it. You have the minus 1 million, don't forget that. Minus 1 million. We need to find A given F at 6% and 10 years. Because then again, this 10 would be 1 cycle. Okay. Then you go to your table, plug in the value, multiply it, and you should get minus $75,870 per year. Because remember, we want it per year. That's why we were looking for the annual worth. Okay, so now that you have all of your, we don't have any other recurring costs, so we only have A1 and A2. So we can go to step 4. And step 4, it's asking us to calculate, the second capitalized cost, which is going to be CC2, which is the present worth of recurring. So it's the present worth of what we got here. And we're going to be, we're not going to be using the factor because remember our n would be infinite. Okay, so we're going to be using the annual worth divided by I, or in this case, it's going to be A1 plus A2, and we divided by the interest. Okay, so our CC2 would be, we put these two together, which both of them are negative, minus 350K minus 75,870. It's 6%, so we're going to divide it by 0.06. And we're going to end up with minus 7,097,833. Okay, we have one more step to go. Step number 5, we calculate the CC total, which is going to be what we found for CC1 and add what we found for CC2. So our CC total would be equal to, they're both negative, so what we found for CC1, it's negative, and CC2 is also negative. It's going to be minus 520 million minus 7,097,833, and the answer would be roughly minus 527.1 million. Okay, so here we're only evaluating one alternative. If we were to have more alternatives, then you would follow all of these steps for each and one of the alternatives, and then you select the numerically largest one.